Okay, picture this, a future where we don't just blast cancer with chemo, but instead we send in a microscopic special ops team. I'm talking about a literal army of tiny robots, way smaller than a human hair, designed to hunt and destroy tumors from the inside out. And believe it or not, this isn't just sci-fi anymore. So let's get into how this tiny tech is waging a huge war on one of our biggest enemies. So, mechanical agitators. When you hear that phrase from Dr. Ning Lu, it sounds almost kind of simple, right? But what it's hinting at is absolutely huge. See, these nanobots aren't just little mail carriers for drugs. Nope, they are active machines. They're designed to physically mess up cancer cells. We're talking about a whole new playbook for treatment here. You know, this is the kind of stuff we've all dreamed about, right? Stuff straight out of science fiction. And now it's actually starting to happen. But, and there's always a but with this kind of thing, the road from a cool idea in a lab to a real-world cure, well, that road is never simple. It's packed with huge challenges and some really tough questions we've got to figure out.
Okay, so to really get why these nanobots are such a game changer, first we have to understand the enemy they're up against. I mean, why is cancer so incredibly hard to treat in the first place? Well, it turns out tumors have some seriously clever, seriously stubborn defenses.
Well, here's the deal. Doctors are basically fighting a war on two fronts. On one side, you've got traditional chemo. And look, it's like carpet bombing your own city to get one bad guy. It just destroys everything, healthy cells included, which is why the side effects are so brutal. Then, on the other front, you've got the tumor itself, which is basically a fortress. It's got these tough cell walls, tiny little pumps that literally spit the medicine right back out, and it creates its own acidic little neighborhood where it can just thrive.
So, how do you get past all that? How do you sneak the medicine past the guards and make sure it actually does its job? Well, that's exactly where our microscopic soldiers come into play.
And listen, this isn't some pie-in-the-sky idea for 50 years from now. This is happening right now. You've got real-world scientists like Dr. Ambarish Ghosh at the Indian Institute of Science who are leading the charge. In fact, his work on magnetic nanorobots just won him a huge award, the Tata Transformation Prize. That tells you just how much potential we're talking about today. So what are these things really? Well, a nanorobot is basically a tiny, tiny machine, a lot of times shaped like a corkscrew. And when I say tiny, get this, it's about 200 times thinner than a single strand of your hair. It's built to be driven and steered through your body. Think of it like a microscopic, precision-guided missile carrying a payload of medicine.
Okay, but wait, how on earth do you drive something that small inside a living, breathing person? That sounds impossible, right? Well, scientists have come up with a whole arsenal of pretty ingenious ways to do just that.
The whole mission basically breaks down into 3 steps. First up, propulsion. You gotta make the thing move. Second, navigation. You gotta steer it to the right address, to the tumor. And finally, the action. That's the moment of truth, where it breaks through the cancer cell's defenses and delivers the goods. All right, the most popular method right now uses something we all get. Magnets. It's pretty straightforward, actually. They coat the nanobots in something magnetic, like nickel. Then, using a carefully controlled magnetic field outside the body, they can make them spin and move. It's literally like driving a tiny remote-controlled car right to the tumor. And I love this quote from Dr. Zing Ma because it explains it so perfectly. When these little spiky magnetic nanobots get to the tumor and start spinning, they're basically acting like microscopic drills. They just poke these little temporary holes in the cancer cell's wall, and bam, that gives the chemo a direct shortcut right inside, completely bypassing all those defenses we talked about. The key thing to get here is that it's a physical attack, not just a chemical one. That's a huge deal. But magnets aren't the only trick up their sleeve. What if you could power these little guys with just sound? I know it sounds crazy, but that's the incredible idea behind using ultrasound. Now this is just wild. Scientists have created things they call microbullets and microcannons. So here's how it works. These little devices carry a tiny drop of a special liquid. When you hit it with a focused ultrasound wave, that droplet just instantly vaporizes and expands. Poof! It creates this powerful little jet of force that fires the nanobot forward, letting it literally blast its way through tissue to get where it's going. Amazing. And this just goes to show you how creative scientists are being. They're trying out chemical fuels that are already hanging out in our bodies, like urea. They're using light fields to guide them. And then, and this is where it gets really futuristic, they're making biohybrids. They are literally hitching a ride on things that already know how to swim, like engineered bacteria, or, get this, even sperm, to carry the payload to the target. I mean, wow. So the potential here is just staggering. It really is. But with any technology this powerful, you have to hit the pause button, you have to step back, and ask some really serious, really tough questions. It's time for the reality check.
I mean, think about it. The power to unleash an army of tiny, remote-controlled machines inside a person's body, that is a monumental leap forward. And it means we have an equally monumental responsibility to make sure we get this right.
And look, this isn't just a challenge for scientists in a lab. It's a challenge for all of us, for society. Researchers have already flagged these 6 major areas we need to worry about. What are the long-term health risks? How can a patient really give informed consent for something so brand new? What about privacy and the data these things might collect? Is this just going to be a treatment for the super rich? How do you even regulate it? It's a lot to consider. And that 5th point, regulation, that's a massive hurdle. Get this, right now, there isn't even one single agreed-upon definition across the world for what nanomedicine even is. And if we can't even agree on the basic terms, how are we supposed to create safety standards that work for everyone? It makes it almost impossible. So here we are. We've got this incredible, world-changing promise on one side, and these really deep, tricky, ethical, and practical problems on the other. So where does that leave us? What does the future actually hold for this technology? Well, to really understand what's at stake, you just have to look at this number. 100%. In a major study, every single mouse with liver tumors that was treated with this combo of nanobots and chemo survived. 100%. That's the kind of number that just stops you in your tracks. It shows you the absolutely life-changing potential we're talking about. And at the end of the day, that's why this research is so important. The goal here isn't just to make a cool new gadget, it's to completely rewrite the rules of cancer care, to make treatments that are more precise, way less invasive, and, this is key, to hopefully make them affordable and available to everyone, everywhere. We are right on the verge of a new age in medicine, one where we can fight our worst diseases at a scale we could only ever dream about before. This technology, it could literally change everything. The only question left is, are we ready for it?